Hello everyone, this is Vanala from SVC, studying in second sem, first year. And today I'm going to explain you guys about Introduction to Integral Calculus. Introduction to Calculus. Calculus is a branch of mathematics that deals with the concept of integration. It is used to find areas, volume, and other quantities that can be represented as accumulation of infinitesimally small quantities. Integral calculus can have various numerous real-life applications in various fields. Finding area under curves. Integral calculus is used to find the area under the curve, such as determining the area of integral shaped regions. For example, it can be used to calculate the area of a field with varying dimensions. It can also be used in determining the area of complex shapes in architecture as well as construction. The area which is given here under the curve formula. Calculating accumulated change. Integral calculus is used to calculate accumulated change or accumulated total from a given rate of change. For instance, it can be used to determine the total distance traveled by a moving object given by its velocity. It can also be used in finance to calculate the accumulated value of investments with varying rates of returns. Related accumulated change to signed area. Net charge of quality. Calculate each region and then combine the area, wherein you can see the change and the sign area. Determining volumes of solids. Integral calculus is employed to determine the volume of irregular shaped solids. For example, it can be used to find the volume of water tank with varying cross-sectional areas. It is also used to manufacture to calculate the volume of complex 3D shapes in designing containers or molds. Here you can see the figure also. Estimating probabilities. Integral calculus is used to estimate probabilities in statistics and probability theory. For instance, it can be used to calculate the probability of a given event occurring within a range. It is also used or utilized in risk analysis and insurance to estimate the likelihood or livelihood for certain events or outcomes. Normal distribution calculating probabilities, you can do it through that also. For example, it can be used to model the growth of population over time, considering factors like birth rate and death rate. It is also used in ecological studies to understand the dynamics of species population. Population growth models. A simple expression that incorporates both assumption is given by this equation. If P is small compared with K, then P by K is close to 0. So dP by dt is congruent to Kp. If P is greater than K, then 1 is negative. So there you can see which is greater and then lesser. Designing optimal structures. Integral calculus is utilized in engineering and physics to design optimal structures. For instance, it can be used to determine the minimum amount of material required for given strength in bridge construction. It is also used for designing efficient shapes for fluid flow or heat transfer. Analyzing electrical circuits. Integral calculus is used in electrical engineering to analyze and design circuits. For example, it can be used to calculate the total charge or current flowing through a circuit over time. It is also used in determining power consumption and energy transfer in electrical systems. Evaluating work and energy. Integral calculus is employed to evaluate done and energy transfer in various physical systems. For instance, it can be used to calculate the work done by force moving an object over a given distance. It can also be used in thermodynamics to analyze heat transfer, energy conversion processes. Summary of energy formulas are given here. In this picture you can see. Conclusion. Integral calculus has various extensive real-life applications in fields including mathematics, physics, engineering, finance, and more. It is used to find areas, volumes, accumulated change probabilities, model growth, design optimal structures, and analyze electrical circuits, evaluate work and energy, and much more. Understanding and applying integral calculus concepts can provide valuable insights and solutions to real-world problems.